When we gaze up at the night sky, we're captivated by the twinkling stars that have fascinated humans for millennia. But what if I told you that these celestial wonders have a dark secret lurking in their midst? Imagine your worst nightmare, a place where nothing, not even light, can escape. A cosmic abyss that defies all known laws of physics, where time stands still and space is warped beyond recognition. Welcome to the world of black holes, where the very fabric of reality is torn apart and where the fate of entire solar systems hangs in the balance. In this journey to the edge of human understanding, we'll explore the life cycle of black holes and uncover the secrets of their existence. You won't want to miss this. Black holes are one of the most mysterious phenomena in the universe. These enigmatic objects are so dense that not even light can escape their gravitational pull. But how do they form, and what happens after they die? It turns out that the life cycle of a black hole is just as fascinating as its existence. One of the prevailing theories suggests that black holes are born when massive stars collapse at the end of their life cycle. When a star runs out of fuel, it can no longer produce the energy needed to support itself against the force of gravity. As a result, the star's core collapses, collapsing under its own weight until it becomes a singularity, a point of infinite density. This process forms a black hole, which is surrounded by an event horizon, the boundary beyond which nothing can escape. But not all black holes are created equal. Some are born with masses thousands or even millions of times greater than our sun. These supermassive black holes are thought to reside at the centers of most galaxies, including our own Milky Way. But how do they form is still a mystery that has puzzled scientists for years. One intriguing possibility is that they grow by consuming the stars and dust in their vicinity. Over billions of years, these black holes accumulate enough mass to become true giants of the cosmos. As black holes grow, their gravitational pull becomes more intense. This means that anything that ventures too close, be it gas, dust, or even light, is pulled beyond the event horizon and into the unknown depths of the black hole. Once inside the event horizon, the fate of any object is sealed. The intense gravity stretches and distorts the object until it is nothing but a stream of particles and energy flowing into the black hole. This process, known as spaghettification, is a gruesome fate that awaits any unlucky enough to cross the event horizon. But despite this terrifying image, the death of an object isn't necessarily a bad thing. In fact, some scientists believe that the death of stars and other objects is necessary for the universe to continue expanding and evolving. It provides the raw materials for new stars and planets to form, continuing the cycle of life and death that has been occurring since the beginning of time. It's important to note that black holes aren't always so massive. They can also be relatively small, ranging from a few to several dozen times the mass of our sun. These intermediate black holes are thought to form through a variety of mechanisms, such as the merger of smaller black holes or the collapse of massive gas clouds. However, the exact details of their formation remain unknown. You might be wondering, why don't black holes eventually run out of material to consume and die themselves? Well, the answer lies in the very nature of black holes. Their insatiable appetite for matter and energy is directly related to their mass. The more massive a black hole, the stronger its gravitational pull and the more material it can consume. This means that for all practical purposes, black holes can continue to grow indefinitely, consuming everything in their path and becoming true cosmic predators. To make matters worse, these cosmic predators aren't just content with eating up everything around them. They also have a taste for kidnapping stars. Yes, you heard that right. Black holes can steal stars from their planetary systems, leaving behind only an empty void where the star once shone. But how do they manage to pull off such audacious heists? It's a fascinating process that involves a delicate balance of gravitational forces and timing. Imagine a star orbiting too close to a black hole. The intense gravity of the black hole tears the star from its course, sending it hurtling towards the event horizon. But before the star is lost forever, it has a chance to escape the black hole's clutches. If the star is massive enough, it can slingshot around the black hole and escape with a newfound burst of energy. But if the black hole is too strong, the star is doomed to be consumed. And that's when the real trouble begins. Once inside the black hole, the star's fate is sealed. The intense gravity stretches and distorts the star until it is nothing but a stream of particles and energy flowing into the black hole. But here's where things get really interesting. As the star is consumed, the black hole gains mass, causing its gravitational pull to become even stronger. This creates a feedback loop that sucks in more and more material from the surrounding area, causing the black hole to grow exponentially. It's like a snowball rolling down a hill, gaining mass and speed as it goes. Over billions of years, this process has allowed some black holes to grow to truly astronomical proportions. Supermassive black holes are the largest known objects in the universe, with masses ranging from hundreds of thousands to millions of times that of our sun. These behemoths are found at the centers of most galaxies, including our own Milky Way. And while they may seem like cosmic monsters, they play a vital role in the evolution of galaxies. The presence of a supermassive black hole at the center of a galaxy helps to regulate star formation and keep the galaxy stable. It's like a cosmic shepherd guiding its flock. But don't get too close or you'll be the next meal. Despite their seemingly destructive nature, supermassive black holes are essential for the health of galaxies. However, as black holes grow, they don't do it alone. They often have companions, stars that orbit the black hole and provide it with a steady stream of material to consume. These stars are known as donor stars, and they play a crucial role in the growth of the black hole. As the donor star orbits the black hole, it loses material due to the intense gravity. This material forms a disk around the black hole known as an accretion disk. The material in the accretion disk is heated to millions of degrees, emitting a brilliant light that can be seen from billions of light years away. The process of a black hole stealing a star isn't just a one-off event. It's a recurring phenomenon that occurs throughout the life cycle of a black hole. As the black hole grows, its gravitational pull becomes stronger, causing more and more stars to fall victim to its clutches. This creates a vicious cycle that accelerates the growth of the black hole and ensures that it remains a formidable force in the universe. And let's not forget about the role of black holes in shaping the very structure of galaxies. As a black hole grows, its gravitational pull influences the motion of stars and other objects in the galaxy, helping to shape its overall structure. It's like a sculptor chipping away at a block of marble, slowly revealing the masterpiece within. But instead of marble, it's space-time itself. So while black holes may seem like solitary creatures lurking in the darkness of space, they are far from loners. They have a profound impact on the universe around them, influencing the behavior of stars, shaping galaxies, and even creating new worlds. Just remember to keep a safe distance. Now that we've explored how black holes steal stars, it's time to delve deeper into the unseen world of these cosmic wonders. What happens inside a black hole? The truth is that once something crosses the event horizon, we can't see what happens next. The event horizon is the boundary beyond which light cannot escape, and it's also the point of no return. Anything that crosses the event horizon is doomed to be pulled into the singularity at the center of the black hole. But that doesn't mean we can't try to understand what's happening. Scientists use mathematical equations to model the behavior of matter near the event horizon, and they've come up with some fascinating insights. According to Einstein's theory of general relativity, space-time becomes increasingly distorted as you approach the event horizon. This means that time slows down significantly near the black hole, making it appear as if the clock stops at the event horizon itself. But it's not just time that's affected. The intense gravity near the black hole also stretches and distorts objects, a process known as gravitational lensing. This effect can be so strong that it tears objects apart, literally stretching them into long, thin noodles. This phenomenon has been observed in gas clouds near black holes, but it would be even more extreme for larger objects like stars or planets. But what happens after an object is stretched and distorted beyond recognition? The answer, unfortunately, is that we don't know. Once something crosses the event horizon, it's gone forever. There's no way to retrieve it or observe what happens next. This is because the light that would carry our observations is trapped by the black hole's intense gravity and can't reach us. So what does this mean for our understanding of the universe? It means that there are limits to what we can know. We can observe the effects of black holes on their surroundings, and we can study the light that they emit, but we can never truly know what happens inside. The event horizon is a veil that hides the mysteries of the black hole from our view, leaving us to wonder what lies beyond. Despite these limitations, scientists continue to push the boundaries of our knowledge. By studying black holes, we gain a deeper understanding of the fundamental laws of physics and the nature of the universe itself. And who knows what other secrets the cosmos holds? Maybe one day we'll find a way to peer beyond the event horizon and unravel the mysteries that lie within. Or maybe we're not meant to know, and the true nature of black holes will forever remain hidden. Thank you for joining us on this journey to the edge of human understanding. We hope you've enjoyed exploring the life cycle of black holes and discovering the secrets of their existence. Don't forget to subscribe for more fascinating content, and leave a like if you learned something new. Until next time, keep looking up at the stars and keep asking questions. The universe is full of wonders, and we're just beginning to understand it.